All right, IED, we're going to be beginning project 2.1.5, Redesign a Protective Case. A couple of weeks ago, we did a protective case design where the earbud manufacturer wanted to base it off of a competitor, and the competitor's case was just too tall. And your process was simple. You were supposed to just make an improvement from the competitor's design, usually by taking the shape and just making it shorter. That being said, some people came up with some really outlandish ideas, and that's okay because there's nothing wrong with that. That's the design process. But we learned from that process that there were a lot of them that needed additional design iterations. And what I mean by an iteration is you need to go back through the design process again and improve your design. So that's what we're going to be doing this time. We're going to be applying the iterative design process to creatively address a need or solve a problem. And we're going to try to make sure that we have this specifically put into place. There are two resources that's going to be really useful to you guys for this project. One of them is the design brief, where whenever we click on it, it will actually have the design brief that you're going to need to fill out for the um, let's see here, define the problem. That's what you'll need for this section. And then for 2.1.5, redesigning a protective case checklist and rubric. This has essentially what I want in order to be able to grade. It's your deliverables for the actual project itself. So let's go ahead and let's look through, in essence, the checklist and rubric. So I'm going to be splitting this apart in class into 5 sections, just like always. Define the problem, generate concepts, develop the solution, construct and test, and evaluate the solution. So what we're going to need for define the problem is a completed design brief with the added design statement and criteria. That's what we'll need for that one. Generate concepts. We need concept sketches and a justification for the solution path. Now, what normally happens with everybody, all of my group tables will just give me concept sketches. Very few people actually give me justification for the solution path. So normally you turn it in halfway and you get half of the grade and you're like, well, what's wrong with this? Why am I getting this? And it's because you're making either half concept sketches, or you're making sketches that don't really even make sense to me, or you're just not showing me that you justified where you went with those concept sketches. The whole point of the concept sketches is so that I can see your process on where you went. Like, okay, I'm going to make these sketches. Which one of these am I going to go with? The one on the left, the one on the right, the one on the top. Let's see. Oh, yeah, the one on the left. Why did you do that? That's a justification. Like, what made y'all choose that specific one? Developing the solution, we're going to need an annotated sketch. We're going to need 3D models. We're going to need assembly drawing and working drawings. There's a lot of stuff for the develop the solution, so I'm going to make this one worth more points because there's just more stuff to turn in here. Constructing and testing, we will not be doing a 3D printed prototype because we just don't have time to be able to do that this time around. And then evaluating the solution, we're going to need to be doing a proof of concept statement. So in other words, everybody's going to be getting points for construct and test. Once you have made it like in the 3D modeling, that's going to be what we're going to go with this time so that we can move forward. So this is the general idea of what we want. I'm going to make a video for each one of these: define the problem, generate concepts, develop solution, construct and test, and evaluate the solution, because I know a lot of people like that breakdown. So you guys have a great day. This is all for the introduction to the project, and I will talk to you guys later.